Assalamualaikum everyone, welcome back to another video of Learner SAP and with another numerical from the prelims paper. So there we have question number 2 part 2, and the question given is compute the range of the ballistic missile when it is launched at 110 meters per second, that is velocity at 70-degree angle, that is our angle of elevation, and what time. Now what time will the missile hit the maximum height? Now they're asking us two things. First we have to find the range, which is very easy, and then we have to find the time at the maximum height. Okay, that's a very easy question. So let's start with this. In the data we have velocity, which is 110 meters per second. Okay, and then we have angle of elevation, that is 70 degrees. We have to find the range, which stands with r, and we have to find the time. Now the time will missile hit at the maximum height. That means that they're asking us about the time of flight. They're not asking about the total time. They're asking about the time of flight at the maximum height. Because even imagine this, if this is so this is a range, and this will be our range, and this is the projectile motion. Now at half the maximum height, at here we have to find the time, and here we always have the time of flight. If they ask us for here, that would be the total time of flight, but here at the maximum height we have the time of flight only, which is given by the formula v naught sine theta upon g. So let's move on with our solution. We have the velocity, we have the angle of elevation, we have to find the range, and we have to find the time, and we should also specify at the maximum height. Alright, so here we move on with the solution. You all know what is the formula to find the range. That is r equals to v naught square sine twice theta. It's not sine square theta, it's sine twice theta. Do remember that. Sine twice theta upon g. Now the velocity is 110 square. Don't forget to square it. Sine twice into angle of elevation is 70 degrees. Divided by, of course, we all know what gravity would be. It would be 9.8. This is acceleration due to gravity, not actually gravity. And you can find out without your calculator, the answer is 793.64 meter. I've already found it out. That is our range. That's it. Now we have to find the time of flight. The time of flight, you know that, is given by the formula v naught sine theta upon, that was the first derivation that we have in our copy in the lecture notes of projectile motion, that is chapter number 4. And v naught sine theta upon g. Now v naught is 110 and the sine of elevation is 70 degrees divided by gravity, which is 9.8. Now bear with me for a few minutes while I find out the answer with calculator. This is 110 into sine of 70 degrees. It gives me 103 divided by 9.8. It gives me 10.54. So a time of flight is 10.54 seconds. That's it. This is the solution for this numerical. Thank you.